When asked to state the implied domain of a function, we need to find what values can be used for x. The implied domain of any function is all real numbers with two exceptions. Actually, there are other exceptions, but they will not be encountered in this course. The first exception is when we have an even root function, such as a square root. If we try to take the square root of a negative number, we get a non-real answer. So x cannot be any value that would cause the radicand to be negative. The radicand is the part underneath the radical. For example, f of x equals the square root of x minus 7. Find the implied domain. To do that, we take the radicand and set it greater than or equal to 0 and solve for x. And we find that in this case x must be greater than or equal to 7. To write that in interval notation, we say that x can be equal to 7 or anything greater than 7, all the way up to infinity. To ensure that we will be taking the square root of a non-negative number. The other exception that we will encounter in this course is rational expressions. If we have a function that involves a rational expression and we have a variable in the denominator, we have to remember that our denominator cannot equal 0. So in this example, to find the domain, we take the denominator and say that it cannot equal 0 and solve for x. And we find that x cannot equal negative 5, because if x did equal negative 5, negative 5 plus 5 would be 0, and our denominator would be 0. To show this in interval notation, we say that x can be anything from negative infinity to negative 5, but not including negative 5, and from negative 5 to positive infinity. Notice that we use parentheses on the negative 5 to show that x cannot equal negative 5. If we do not have either of these situations, then our implied domain will be all real numbers.